Let's turn on the camera. 5A. Turn on the light. Let me turn on my other light. There we go. All right. So you want to do 5A? We'll do 5A.
Yeah.
If it would make you happy, absolutely. No problem. So 5A. 5A is a tricky one because, so here's what the instructions say. Here. The instructions say find all roots to the following function and then state the multiplicity of each. So we're going to do this one right here, right? So let me write it down. I'm going to set it equal to 0. X to the fourth plus 10x squared minus 25. Okay, so it's factorable for sure, but the issue is that it's not quadratic. So when we factor it, here's what you're going to get. You're going to get x squared plus 5 squared. You see? Are you good with that, Ruben?
Yeah. I got to there,
okay.
but then
got to there.
Yeah.
All right, so let's take each factor and set it equal to 0. Normally we wouldn't have to do this if we weren't concerned with multiplicity and imaginary roots. We wouldn't have to do this. Like we could just do one of the factors, right? Okay, so x squared equals -5. And the same thing over here, right? So we're going to get the same answer over here. So x is going to be equal to, take square root, you're going to get plus or minus the square root of 5i. So you're going to have the square root of 5i with a multiplicity of 2, and you're going to have negative square root of 5i with a multiplicity of 2. Does that make sense? Ruben left, and then he just rejoined us. How you doing on that one, Ruben? Good? For those of you who came in late, because since it didn't record, do you guys want to go over this one again since we're here anyway? Because one of the issues that came up is, like Ruben was saying, can't you just use inverse operations for this right here? And you can. The problem is you're not going to find all of the roots. You're going to find the real roots, but you won't find the imaginary roots. So, Ruben, are you good with this one?
Yeah, it's because I was gonna check something in the answer key because.
Oh yeah, I changed it. I had this, right?
Yeah.
Originally, yeah.
I
deleted it and then re-uploaded it.
I hit the back button and then it disconnected, even though I was in the other tab. So yeah.
Oh well, okay, yeah. So
then,
originally, yeah, go ahead.
Which one is it?
This.
The top one?
Yeah, because you got to take the square root. So when I typed it, I forgot to write the square root thing. So I went back and I fixed it, and then I reloaded it. I thought I reloaded it in Google Classroom too, but maybe I didn't.
Oh, okay.
But if you did it early and you graded it right away, then I had that typing error. So it's this, for sure. All right. Let's see. Do you guys want to do, since we're here, and since I didn't record it, let's go ahead and do this one right here. Let's find, so we got to find all roots. And then we also have to name the multiplicity, right? The instructions say, find all of the roots to the following functions and state the multiplicity of each root. So this one is like you can use inverse operations. And if you're going to find the real roots, you would just get this. Like you would subtract 64, and then you take the cube root of -64, which is -4. The problem is there are 3 roots, and that's only 1. It has a multiplicity of 1. So, and that's the thing, like Ruben and I, we just went through, right? So like this right here is cubic with a multiplicity, with that x-intercept of -4 and multiplicity of 3, but when you write that one out, I don't even remember what it was. It's like a big old ugly thing. Oh man, but yeah, because it's going to be x plus 4, x plus 4, x plus 4. So that's x squared plus 8x plus 16 times x plus 4. So I think it was x cubed plus, oh man, I don't even remember. I don't remember. It was something like 12x squared plus 32x plus 64. It was something like that by memory, like because we just did it a minute ago, but I forgot to record. But either way, this has one solution of x equals -4 with a multiplicity of 3. This one, totally different. So you have to recognize that it's the sum of cubes. You see it's x cubed plus 4 cubed. So you have to use, you have to use the formula, x squared minus 4x plus 16. And so this one is x equals -4 from that factor. And for this one, you have to use the quadratic formula. 64 over 2. So x equals 4 plus or minus the square root of -48 over 2. Square root of 48 can be simplified. So what you're going to get is you're going to get 4 plus or minus 4 root 3 I over 2. Problem is that's not written as a complex number. So you need to reduce it all and you need to rewrite it. So you know the 2's are going to reduce with the 4's. So here's what you're going to get. You have one answer that's 2 plus 2 root 3 times I, multiplicity 1. And you have 2 minus 2 root 3 I, multiplicity of 1. We also had -4 multiplicity 1. So it's cubic, so we have 3 solutions, 1 real, 2 imaginary. And if the imaginary is complex and the real part is not 0, then you need to write it in that form. So it's the form for complex numbers is A plus BI. So the imaginary part goes second. Okay. Well, man, happy Monday. Any other you guys have any other questions on that homework? I know some of you guys like Omar and George, you're here for the whole thing. Jesus too, and Angela. But you guys have any other questions on any of these others since we're here? All right. Well, now, hopefully now for sure, we're recorded and we're done. So let me make sure. Oh man, beautiful. All right. Well,